Hello and welcome to CCIA News Scotland. Today we will have a special report for you on the new Queensferry crossing, which is currently under construction. This will feature an overview of the bridge and how today's climate and future climate change projections will affect the structure. It will also assess the potential transboundary implications, as this will become a critical link in the transport passageway in eastern Scotland. To present this, I will be joined by James, our science correspondent, Kevin, our on-the-ground reporter, and Kenneth, one of the bridge engineers. The Queensferry crossing is a globally unique bridge, and when complete, the 1.7-mile structure will be the longest three-tower cable-stayed bridge in the world. It is currently in construction to the west of the existing Forth Road Bridge across the Firth of Forth. The Firth of Forth is 55 miles in length, with a maximum width of 19 miles at its mouth, and represents the most substantial estuary on the east coast of Scotland. In recent years, the Forth Road Bridge has shown signs of significant deterioration, and on the 4th of December 2015, it was closed to all vehicles due to structural faults, creating major disruptions and chaos, not fully reopening until February 2016. It is therefore no longer deemed viable as the long-term main crossing between Fife and East Lothian. In 2006, Transport Scotland carried out the Forth Replacement Crossing Study to examine a wide range of options for replacing the Forth Road Bridge. At the end of 2007, Scottish ministers announced their intention to build a new cable-stayed bridge, and construction began in 2011. The Queensferry crossing is due to open in May next year, and will be essential for people to commute and for goods and services to be delivered across Scotland, carrying the 60,000 vehicles a day that cross the current Forth Road Bridge now. The mean annual temperature in Fife and East Lothian is approximately 9 degrees Celsius. As you can see from the graphs, January is the coldest month, with mean daily minimum temperatures of 2 degrees Celsius, and July is the warmest month, with mean daily maximum temperatures of 19 degrees Celsius. Much of eastern Scotland is sheltered from the rain-bearing westerly winds. This shelter reaches its greatest potential along the coasts of East Lothian, Fife and the Moray Firth, where areas receive approximately 700 millimetres of rainfall in an average year. From the graph, you can see October has the highest average rainfall, with the spring months receiving the lowest. Severe weather events which have affected the current Forth Road Bridge and surrounding areas in the past are storms and high winds. For example, gusts of up to 90 miles per hour from Storm Gertrude and Henry resulted in the closure of the Forth Road Bridge in January and February 2016. Additionally, on the 1st of December 2010, the bridge was closed for the first time due to heavy snow after several accidents.
The uncertain nature of climate change means that it's very difficult to predict what the impact of climate change will be on structures such as the new bridge that we are talking about. In many parts of the world, areas such as this are predicted to be swallowed up altogether by the sea due to rising sea levels. Fortunately for Scotland, there is not predicted to be a large amount of sea level rise here due to post-glacial rebound. However, this doesn't mean that there won't be additional risks to the bridge, as well as to the traffic crossing it, if extreme events such as storms become a more regular occurrence in the future. Indeed, the IPCC has predicted that by 2050 there will be a significant increase in rainfall over eastern Scotland.
As we can see from these figures, the latest Met Office climate change predictions for Scotland show an increase in the summer temperatures of around 3 to 4 degrees and an increase of winter rainfall of 10 to 20%. Furthermore, here we can see the different predictions for sea level rise for the east coast of Scotland. The top and bottom lines represent the upper and lower bounds respectively, with the middle line representing the most likely scenario. These predictions assume the highest greenhouse gas emission scenario, so the real impacts in 2050 could be less severe than this, as long as action to reduce greenhouse gas emissions is taken immediately.
More frequent heavy precipitation events will have the effect of increasing the amount of water flowing off the land into the Firth of Forth. This increased flow of water will then enhance the risk of coastal erosion in the area, as well as increasing the rate of degradation of the bridge stanchions. However, it must be noted that the impacts of climate change predicted for this area are not supposed to be too strong by 2050. Therefore, there is a reasonable cause for optimism when thinking about the long-term viability of the new crossing.
The Queensferry crossing is a major transport link connecting Edinburgh with the north of Scotland. Therefore, climate change impacts will not only be local but also regional. Direct impacts to the bridge should be minimal, as the bridge has been designed to last for 150 years, which should contain features to minimise extreme weather events.
I then interviewed Kenneth, one of the bridge engineers, and asked him what are the main structural differences between the Queensferry crossing and its predecessor.
Basically, if you see the feature of the bridge, the first one is the new bridge called a cable stayed bridge, and then the other one is the old one, which is called the suspension bridge. So both things look quite same, but basically the structures, the characteristics are basically totally different.
In suspension bridges, the cable rides freely across the towers, transmitting the load of the anchorage at each end. In cable-stayed bridges, the cables are attached to the towers, which alone bear the load.
Bearing this in mind, as we know, the old Forth Road Bridge had to close a number of times. Will these new design features in the Queensferry crossing mean that it will have fewer road closures in the future?
So because of the suspension bridge's characteristics, it basically allows the vibrations and the sways on it. So to do sustain the bridges, we need two loads in the vertical side and the lateral side. On the vertical side, it leads to the vehicle's load, and the lateral side is more in terms of the wind power. So firstly, when you've seen that, it looks really great and nice, but it accumulated again and again, and when it meets the regional frequency of its own bridges, the amplitude of the bridges are getting bigger and bigger, and finally it meets the unendurable condition of the road for drivers. And also, there are two main characteristics on the new bridge. The first thing is in terms of the height, and the second thing is in terms of the wind shielding alongside the bridge. The first one, the height of the bridge is 207, which is the most highest bridge in the UK, which is 50 meters more higher than the old one, which admits the whatever ship sizes and the heights can admit to go through under the bridges. And secondly, because of that wind shielding on the bridge, it will protect the vehicles and the crossings on the bridges here and there, regardless of the wind conditions.
On the other, CXification may be of an issue. This is due to the fact that increasing CO2 emission will cause the world's ocean to acidify, directly corroding in the tower structure of the bridges, undermining its structural integrity, and perhaps could increase maintenance costs in the future.
So rather than the bridge itself being directly impacted by proposed climate change, it will more likely be the daily users of the bridge, as well as businesses and services that rely on it as a major artery connecting Edinburgh with the north of Scotland that will be most at risk. Most obvious is transport, as a change in climate will cause not only changes in recreational habits, such as a warmer Scotland may mean more tourists travelling north, increasing the load on the bridge, or conversely warmer winters meaning less traffic to the decaying bones as the ski season is shortened.
Although the new bridge will make traffic less susceptible to storms and strong winds, thought to intensify with climate change, high-sided vehicles will remain vulnerable to windier conditions, which could have fatal consequences but also knock-on effects for the local and regional economy, as bridge closure will disrupt supply chain logistics such as deliveries.
It is essential that critical infrastructure in Scotland, such as the Queensferry crossing, are constructed with climate change challenges in mind, as although eastern Scotland may avoid some of the most devastating effects of climate change up to 2050, an increase in rainfall and extreme weather events could pose a serious threat to the bridge and its users. Fortunately, Transport Scotland appear to have chosen a more suitable design for the Queensferry crossing than that of its predecessor, and resilience to an ever-changing climate has clearly been prioritised to a greater level than before. Once opened, a large part of Scotland's economy will become increasingly reliant on this key transport link, and only time will tell if the crossing really is up to the challenges that a future climate may pose.